What if I told you that you could turn a handful of ordinary-looking gray stones into a flame hot enough to melt solid steel? It sounds like alchemy, but it's actually one of the most elegant reactions in industrial chemistry. To understand how it works, we have to look at this substance here, calcium carbide. On the surface, it looks like a dull, heavy rock, but inside its molecular structure, it's holding a tremendous amount of potential energy, just waiting for a trigger. Let's visualize what happens when we bring these rocks into contact with something as simple as water. Watch closely as we drop a piece into this flask. Notice the reaction is almost instantaneous. The surface begins to fizz and hiss, and bubbles of gas rapidly crowd the container. So, what's actually happening at the molecular level? Think of it as a chemical trade. A calcium carbide molecule consists of one calcium atom bonded to two carbon atoms. But those two carbons are special. They are already locked together by a powerful triple bond. When water, H2O, enters the scene, the calcium atom decides it would much rather be with the oxygen and hydrogen from the water. As you can see in this diagram, the water molecules essentially attack the carbide. The calcium breaks away to form calcium hydroxide, which is that white, cloudy precipitate you see settling at the bottom of the flask. This leaves our two carbon atoms alone, but they don't stay alone for long. They quickly grab the leftover hydrogen atoms from the water. The result, C2H2. This is acetylene. And here is the key insight. That triple bond between the two carbon atoms that we saw earlier, it stayed intact throughout the whole process. In the world of chemistry, a triple bond is like a tightly coiled spring. It stores a massive amount of chemical energy in a very small space.